In this video, we'll discuss circumference and area of circles. Now, the circumference represents the perimeter of a circle, and we can use one of two formulas to help us, depending on if we have the diameter or the radius. If we have the diameter, we do diameter times pi. If we have the radius, we do 2 times the radius times pi, because the diameter is double the radius. So here's an example. Say we want to know how many more inches is the circumference of a 12-inch pizza in comparison to a 10-inch pizza, and we're going to round that to the hundredth. So here, we're given the diameters. They're 12 inches and 10-inch pizzas. So we're going to use the circumference with the diameter formula. So that would be 12 pi inches for the 12-inch pizza and 10 pi inches for the 10-inch pizza. Their difference would be the subtraction of those two values, which would be 2 pi inches, which is about 6 and 28 inches. Now we can also talk about the arc length, which is the length of the circumference between an intercepted central angle. So here we're just looking at a fraction of the circumference. So when we think about it, we're going to just take whatever fraction of the circumference we have, which will be the arc measure over 360. So think about what the circumference means. That can be the diameter times pi or 2 times the radius times pi. So it's just the fraction of the overall circumference that we're looking at. So in this case, we want to determine the arc length of GE on circle T. So if we did this, we'd say, okay, we have the 60-degree central angle, so that means the arc measure is 60 degrees. And we know the radius is 9 units. So we have those two pieces of information. We can now figure out what fraction of the overall circumference we have in this circle. So we plug in the parts we have. That would be 60 over 360. And then we have the radius. So we're going to do 2 times the radius times pi. That's a sixth of 18 pi, which would be 3 pi. And if they wanted it approximated, we would then approximate that value. But always start with it in the exact form. Now we can also talk about the area of a circle, which is all that space inside a circle. For this, we use area as pi times the radius squared, or the radius squared times pi. So we do need the radius in this case. So when we think about our pizzas that we had a minute ago, if we want the area and compare the areas of a 12-inch pizza to a 10-inch pizza, we first need to calculate the diameters into the radii. So that would be 6 inches and 5 inches. Then we calculate the area for each pizza. So that'd be 6 inches squared, so 36 pi square inches. And then 5 inches squared would be 25 pi square inches. That means when we find the difference, we'd be subtracting those two values, which would be 11 pi square inches for the exact value, and about 34 and 5600 square inches if we want the approximate. Now, just like we can find a fraction of an arc length, we can also find a fraction of the area, which is called the sector. So a sector is just a fraction of the overall circle. And just like when we were calculating before the arc length, we can do that arc measure over 360. And again, just remember the arc measure is the same as our central angle, and the arc measure over 360 is just representing a fraction of the circle. So I can get a problem where maybe they say this instead of giving me an actual arc measure like we had in the previous problem. Here, we're told that a pizza is cut into 8 slices, and we know how many square inches is each piece of pizza. We're not given an arc measure, but we do know the circle has been cut into 8 equal sections. So that means when we think about the circle, we're looking at 8 different slices, with each of them having a radius of 6 inches. So we know we're looking at a fraction of 1/8 and a radius of 6 inches, and we can use that to find our area of the circle, or our area of our sector. So that's 1/8 of 6 inches squared times pi, which would be 4 or 4.5 square inches, which is about 14 and 1400 square inches for each piece of pizza.